Hello, abstract algebra students. We will now prove that symmetric difference is associative on the power set. So we have already proved the commutative property for symmetric difference on the power set. And now we want to prove the associative property. So this will be another set theoretic identity that will lead us to another truth table. So let's start with a clean virtual blackboard. Clean. Symmetric difference is associative on P of M. Now, let's first figure out what we want to show here. We are applying the general definition of the associative property to the set P of M. So elements in P of M are sets, so they should be capitalized. So we want to show for all capital A, capital B, capital C in P of M. Now, our operation is symmetric difference with the triangle here. So asymmetric difference B in parenthesis, symmetric difference C equals A, symmetric difference B, symmetric difference C. So we are trying to prove a quantified if-then statement. So that means we need to begin by letting A, B, C elements of P of M be given. So we let arbitrary A, B, C, which are in P of M, be given. Now, if A, B, and C are in P of M, it means that A, B, and C are subsets of M. So A, B, and C are sets. So again, this is a set theoretic identity that we want to prove. And we know from foundations, the way we prove it is to make a truth table. So consider the following truth table. We know the truth table will have to have 8 rows because X is a member of A, X is a member of B, X is a member of C. There are 3 independent statements. So we will need the heading row and 8 rows below it for 9. Now, if we think about our columns, we need X is in A, X is in B, X is in C. X is in asymmetric B, X is in B symmetric C, X is in the left-hand side, X is in the right-hand side. So we're going to need 7 columns here. And our columns are going to look like X is a member of A, X is a member of B, X is a member of C, X is a member of A symmetric difference B, X is a member of B symmetric difference C. Excuse the background noise. My neighbors were out skateboarding. X is a member of A symmetric B symmetric C with A and B in parentheses. And X is a member of A symmetric and then B symmetric C in parentheses. Okay, so let's fill in these columns. The first 3 are just how we fill in the independent columns of the truth table. So the first column is the first half true, the next half false. The second column is 2 true, 2 false,